In this video, we're going to talk about systems of equations with three variables. First thing we're going to do in this video specifically is to talk about what these solutions to these systems look like. So remember that a solution set to a system of equations, and this could be a system with 2 equations, 3 equations, 4 equations, but also 2 variables, 3 variables, 17 variables. The principle is still the same. And the solution set is just a set of all points that make all the equations true. Alrighty, so let's do a little comparing and contrasting between 2-dimensional systems and 3-dimensional systems. 2D and 3D. And what I want to do is show the possible, well, I guess just the possibilities of systems. So 2-dimensional systems, and we'll just assume that in a 2-dimensional system there are 2 equations, and in a 3-dimensional system there are going to be 3-dimensional system with 3 variables, there will be 3 equations. And again, we're talking linear systems specifically, so all the equations are linear equations. Well, the most typical one we'll see with 2 dimensions is something like this. You have the line there, and you have a line there. In this case, there's just one solution here, and it's just this point right here in red. So our solution set there is a single point, a point. Well, that's one possibility, but there are a couple others. We could also have parallel lines, in which case we would have no solution. No solution. And the last possibility here would be if the 2 lines were actually on top of each other. So there's one line, and the second line is, well, maybe I'll draw it in green here. It basically is on top, and so it's really the same line. And so in that scenario, you'll have infinitely many solutions. The graphs, we would say that the graphs coincide with each other. Infinitely many solutions. So let's take a look now if we have 3 planes. And if you want to take a look at this, which I definitely would encourage, you can have 3 pieces of cardboard, or maybe 3 pieces of paper. 3 pieces of cardboard would probably be better because they are stiff and they won't flop around. But think about all the ways that they could interact with each other. Well, one thing that could happen is that they could form, well, all 3, they could all be parallel. So I'll draw this, or I'll try to draw this. So here's a plane right there. Underneath it, this one might be like so, like that. And maybe this green one is parallel to the red one, but it's a little bit closer. And so you wouldn't quite see it. They're all, because it's a little bit covered, but something like that. They're all parallel to each other. Well, if that's the case, of course, there's still no solution, because there's no points that are common to all 3 of them. Actually, if they're all parallel, there are no points common to any of them. And of course, you do have the possibility that where all 3 planes are exactly on top of each other. But that would be kind of trivial in that sense. And again, once again, there would be infinitely many solutions. Infinitely many solutions. But I want to talk about when they actually intersect in somewhat interesting ways. Well, there is this possibility as well. And this one, I mean, I can't actually draw it. But if you look at it profile, then you have something like this. So you have one plane that looks like that. And so what I'm imagining is that you're basically looking straight on the side of a piece of paper. So you essentially only see a line. You could also have something like this, where your second plane crosses it. Okay, and so 2 planes form a line when we cross. We talked about that in the last video. But the third plane might come out like this. And so in this case, there actually would still be no solution, because, and again, it depends on how the planes are tilted exactly, but in this case, there's no point that's on all 3 of them, because you have points that are shared between the green and blue one right there, the blue and red, and the green and red, but none of those lines would interact reach each other. That's kind of a special scenario. So let's talk about what we could do then to actually make all three of these planes share some common points or a common point. Well, think about this. What if I just took that red plane and then scooched it up where it crosses that line where the green and blue plane intersect? Now, I'm actually going to try to draw this in a second. All right, I've mentally prepared myself to draw these three planes, so let's try it. So we kind of did this in one of the previous videos. So here's the green plane, that's right there. The blue plane, well, we know that when I cross two planes, I will end up with a line, so I'll draw that line of intersection. This blue plane's going to keep going back there. And it will keep reaching back, and it'll poke out behind the green one like so. Let's do some erasing, because the erasing is really where the magic happens, to really get the 3D-ness showing. Show that right there. And so there's two planes, and I just need to now get the red one in there, and I'll draw it like so. So it's going to be coming out more at us, like this. And it would poke out behind us, back there, and maybe it would finally come back. Oops. Like so. Not my best work, but definitely I think gets the idea across, so I will take it like so. So we could see here that what this intersection would look like, the intersection, well, they actually have this orange line all in common. You can essentially think of these as pages in a book that have just all been opened up at different angles. And so in this case, the solution, there's infinitely many points, one in the solution, but the solution set is actually a line that is shared or is common to all three planes. That is actually only one way we could draw a solution, but there's another way. That you could take three planes and intersect them, mush them together, so that they all have a common point. And that would be essentially if you just took the plane, maybe the red one, and rotated it. And so I'm going to try one more drawing, which is actually one of my favorite drawings, and let's just go for it. So I'm going to start off, I probably should have just copied this part, once again, with the green plane there. The red one, or sorry, the blue one goes right here. And I'm going to open this one up a little bit more than it was last time. Oops. This is definitely a fun project to do, just drawing stuff in 3D. Oops, that should just be solid there. Okay, and now, okay, bear with me. This red plane is being wedged in sideways, so it's not standing up. And so this one would poke out like so. And you would see it like so. This red plane, it would cross through the green one right there. It would also cross through the blue one right here. But it would also poke back through the blue one, or through the green one. You'd see it back there. Then you'd see it also kind of chop through the blue one over here. And it would stand back there. And likewise over here on the left side. And again, folks, we are just kind of having a good time here, enjoying our three-dimensional drawings like so. Now hopefully you can kind of see what I'm getting at. And so the intersection of the green and the blue one is this blue line right here. The intersection of the red plane and the blue plane is this yellow part right here. And the intersection of the red and green is this pink one right here. And where do all three of those intersections meet? Well, they all meet right here at this gold point right in the middle there. And so you could have three planes where their solution is a line, as we saw previously, Or you could have them oriented in such a way that the solution set is a single point right there. Oopsies. Man, I'm actually really proud of that drawing. This is actually the scenario that we're going to see the most. This scenario over here where the solution set is aligned is actually very kind of complicated. Not that you couldn't handle it, but this is definitely the more common one and where we're going to spend most of our time. Alrighty, so in the next video, we're going to talk about how to actually solve this system. I had to just add one little bit because I realized there was a tiny mistake in my drawing and I just couldn't stand it. These little lines, this blue line here and that green line should be dashed. And so there we go, our final finished picture. I think that looks pretty dang good. Okay, actually I just decided to erase all the dashed lines and now I think it looks even better.